Hi everyone. This video is the second part of the algebra section where we're going to talk about how you solve equations. And this is going to go with the homework from sections 2.8, 5.7, and 5.8 in the textbook. So let's get started. So first, let's talk about some vocabulary. In the last section, we talked about what expressions are. In this section, we're going to talk about what an algebraic equation is and the difference between it and an expression. In an equation, you have an equal sign. That's the main difference between an equation and an expression. With an equation, now that you have an equal sign, you can solve for your unknown variable. So it's usually x, so you will be able to find a value for x now. The value that makes that true is called the solution. It's whatever x is equal to. So, as I mentioned before, the main difference between an expression and an equation is expressions do not have equal signs in them, which means that all you can do with them is to either evaluate them if you're given their values, or you can simplify them like we did in the last section. With an equation, since they do have an equal sign, now we can use properties of equality to work our way backwards and come up with a value for the variable. So the properties of equality that we use when we're solving equations are called the addition and subtraction properties and the multiplication and division properties. And basically what they say is, whatever you do to one side of the equal sign, you have to do to the other side to keep the equation balanced. So if you add something to one side, you add it to the other. If you subtract something from one side, you subtract it from the other, and so on. The way you decide what to do is you're going to use what's called inverse operations. So if you see addition, you're going to subtract. If you see division, you're going to multiply. You're going to do whatever is the opposite operation to whatever's being done to the equation, and you're basically trying to unwrap this ball of confusion here to solve it. So basic steps for solving algebraic equations are this. You want to first try to simplify as much as you can. We already talked about how you use the distributive property and how you combine like terms. So whatever you see that you can do to the equation first, try to simplify it first. It makes the next steps a lot easier. Then for step 2, you want to move all of your variable terms to the left side of your equal sign, and all of the constant terms, which are just the regular numbers, you're going to move those to the other. You're going to move those to the right by either adding or subtracting whatever you see. At the end, you're going to either divide or multiply, but in most cases you're going to divide by the coefficient. And then you're going to check it by substituting. Okay, so let's take a look at an example. So this one is 2x minus 5 plus 3x equals 20. The way I like to start when I'm solving equations is to draw myself a line down the equal sign, and then that helps me to separate the left side from the right. The first step when you're solving is to try to simplify as much as you can on one side or the other. So on the left side, I see that I have like terms that I can combine. So I'm going to do that first. I'm going to take my 2x and my 3x and combine them together, which will give me 5x. And then I'm going to bring everything else down. Then I'm going to take another look at it. I see that I have now all of the x terms on the left, which means I need to move all of the numbers to the right. Anytime you move something from one side of the equal to the other, that's when you use the inverse operations. So if I'm subtracting 5 right here to start, then I'm going to add 5 to solve. So whatever I do to one side, I do it to the other to keep this balanced. And then I'm going to recombine and see what I have. Now right here, I got to make sure that I've done the right thing by checking. Those two should be opposite so that they cancel, which is the goal. We're moving from one side to the other. So we want those to cancel out, and we only want variables on the left and the numbers then are going to regroup on the right. So now we have 5x equals 25. And at this step, now that the x's are on the left and the numbers are on the right, this is when you divide by the coefficient. So the coefficient here is 5, so you're going to divide both sides by 5. And that will cancel the 5's on the left, which will leave you with x. And then 25 divided by 5 is 5. So here's your solution, x equals 5. Now to check this, we're going to take the 5 that we just figured out and substitute it in and evaluate this original equation by plugging it in. So here where I have the x, I'm going to put in the solution I got. And here I have another x, I'm going to substitute in the solution that I got. And then I'm going to work it out with the order of operations. So multiplying first, the 2 times the 5 is 10, the 3 times the 5 is 15, and I brought everything else down. And then with the order of operations, when you're adding and subtracting, you go left to right. So 10 minus 5 is 5. 5 plus 15 is 20. Since we get the same number on both sides, 20 equals 20, that means that our original solution of x equals 5 was correct. And this one's done. Okay, so let's get started on some of these guided practice problems. So for number 1, we got 3x plus 7 equals 28. And first step is to look and see if you can combine anything on the same side. So you have 3x plus 7. Those are not like terms, so you cannot combine them. And over here, you just have 28. So the next step is I'm going to move all of the variables to the left and the numbers to the right. All my variable terms are right here, so they're already on the left. I got to move all of the numbers, so the 7 has to go over to the right. Since I'm going to move it from the left to the other side, I have to do the opposite of what I see. So this is a plus 7, I'm going to subtract 7. That way those two are opposite and they will cancel out. And whatever I do to the left, I got to do over here to the right. So I'm going to subtract 7 over here. Then I'm going to regroup. The 7's canceled over here, and all I have left is 3x. So my variables are alone on the left, and then 28 minus 7 is 21. Okay, now that I have the x's on the left and the numbers on the right, I divide by the coefficient. So I'm going to divide both sides by 3 so that these 3's will cancel and all that's left is x. And then 21 divided by 3 is 7. That one's done. To check it, which I'm going to only do the check for this one, but just to show you, but to check it, I'm going to take the original equation, 3x plus 7 equals 28, and substitute the 7 that I got for my answer in place of the x. And then I'm going to follow the order of operations and see what happens. So I'm going to multiply first. 3 times 7 is 21. Then adding 21 plus 7 is 28. Since I get the same thing on both sides, it says 28 equals 28. That means that this 7 was right, and that's the check. Okay, so let's move on and look at number 2. So we have 14 minus 5x equals 59. Again, I can't combine these two terms because this one has the x and this one does not. So I need to start moving things. The x's are over here on the left already, so that means the 14 needs to move over. When you move something, you have to look at the sign in front and do what's opposite of that. So in this case, the 14 is positive. So I'm going to put a plus sign in front so you can see this a little clearer. if that's a positive 14, then to move it, I need to make it negative. Which means I'm going to subtract the 14. That way those two will cancel, and whatever I do to the left, I'm going to do over here to the right. And then I'm going to regroup. So the 14's canceled, and I'm going to bring down what I have left over here, which is the minus 5x, or negative 5x. And then I'm going to subtract the 59 minus the 14, which is 45. Now my x's are on the left and the numbers are on the right, so I'm going to divide by the coefficient. The coefficient in this case is negative, so I need to divide by negative 5 on both sides. These two things are not going to be opposite when you're dividing. You're going to divide by exactly what is in front of x. So negative 5 is what's in front. You're going to divide both sides. That way, that will cancel. And then positive 45 divided by negative 5 is negative 9. All right, and that one's done. Let's take a look at the next one. Okay, this one here, when I go to look at what I have, I can't combine 5x with 12, and I cannot combine 8x with 24. So I can't simplify anything. That means I need to start moving things back and forth. But what's different about this one that we haven't done yet is that now you do have x's on both sides. So the first thing you need to do is gather up all of the x's and get them all to one side. So that 8x is going to move to the left. Since the 8x is positive, we're going to subtract it. For the same reason as the last question, you can put the plus sign in front if you want. You're looking at the sign in front to decide what to do here. Whatever you do to this, you're going to do that over here. All right, so let's regroup and see what happened. You have positive 5 minus 8, which is negative 3x. I'm going to bring down the minus 12 for now. And then the 8x is canceled, and there's 24 left on the right. Okay, so the x's are on the left. Now let's move the numbers to the right. So the 12 needs to move over. It's a minus 12, so we're going to add. And we're going to do that to both sides. And regroup. These 12's canceled. Negative 3x is over on the left by itself. And 24 plus 12 is now 36. All right, so the x's are on the left, the numbers are on the right. This is when you divide. So I need to divide by whatever's in front of the x, the coefficient. The coefficient is negative 3, so I'm going to divide by negative 3 here and divide by negative 3 here. And that way, negative 3. Okay, so for the last one, let's take a look at what we got here. The first thing I see is that on the left-hand side, I got some things that I can simplify first. So that's what I'm going to do. I can't combine the 2x with the 8, but I can distribute, and that will remove the parentheses. So we're going to take the 5 and multiply it to the 2x. 5 times 2x is 10x. And then take the 5 and multiply that to the minus 8. Think of that as a negative 8. It would be positive 5 times negative 8, which would be negative 40. You write it as a minus 40. This 2 is not inside, so that just gets brought down. Okay, now on the left side of the line of the equal sign, I still see stuff that I can combine. So I'm going to put together my two constants, my two numbers. Negative 40 minus 2 is negative 42. So those two can be combined, and then I'm going to drop the 10x down and bring the 18 down. Okay, as far as simplifying, that's as much as I can do. I can't combine the 10x with the 42 because this one does not have the x. So now I'm going to look and see what I have. I have variables on the left. I need to move the numbers to the right then. So this 42's got to move. I'm going to add it because I want those two to be opposite. And then whatever I do to the left, I'm going to do the same thing to the right. And regroup. These are going to cancel. 10x is left. And 18 plus 42 is 60. Now that I have my x's alone on the left and the numbers alone on the right, I'm going to divide by the coefficient. So divide both sides by 10. 10 divided by 10 is 1, that cancels. So x is left, and 60 divided by 10 is 6. All right, so next we're going to move on and talk about solving applications with algebra. In order to do that, you need to be able to translate the word problem that you're given into what it means equivalently in math. So you're going to see words within the problem written out in English, and you're going to need to translate them into their mathematical symbols. So we've already looked at this list of keywords before. So just to remind you, anytime you see these, they mean specific operations. I want to focus in on the subtraction ones that are starred and bolded here. Subtracted from, less than, and fewer than. When you come across those get translated backwards. So if it says 3 less than x, that means x minus 3. You just flip the order around. Okay, so use this chart as your English to math translating dictionary. Like if you were traveling to a foreign country and you didn't speak the language, this is how you could translate. So there's also a few things we need to look at that we haven't talked about yet. Now that we're dealing with algebra, whenever you come across the phrase a number or the number, that means you don't know it, so we change it to a variable. And I'm going to use x just to keep consistent with what we've been using. You also might see the phrases the sum of, the difference of, the product of, and the quotient of in a sentence. Those 4 phrases tell you what symbol you're going to use, but the word and that will be later in the sentence is going to tell you where to put it. And that's going to make probably more sense when we do the example. And then last but not least, when you have an addition or a subtraction phrase that comes after something else, then you need to put parentheses around the whole thing because the multiplication has to multiply everything. All right, so let's take a look at some of the examples here from the notes. They want you to translate the sentence, each of these, into an algebraic equation using x for the unknown, and then we're going to try to match up our answers to the box over here on the right. So for the first one, it says 3 times a number is 15. So what I'm going to do is take the words individually and translate them to what they mean in math. So obviously 3 is a 3. Times means multiply. A number is x. The word is means equal, and then 15. So I do a rough translation first, and then I clean it up as a second step. So 3 times x is the same thing as 3x. So 3x equals 15. would be the translation for number 1. That makes this choice B. Okay. Next, 3 less than a number is 15. So 3 less than means subtract a number. X is equals 15. Okay, so I do a rough translation just like with number 1, and then I'm going to clean it up. So I notice that I'm subtracting. I'm going to check and make sure that this is not one of the backwards ones, and it is. Less than gets translated backwards. So when I go to write my final answer, I need to switch the place around. So X comes first, then minus 3, and that equals 15. And that looks like choice H then. Number 3 says twice a number added to 3 is 15. So twice means times 2. A number X added to plus 3 is 15. So there's my rough translation, and then I'm going to clean it up. The only thing I can really do with this is take the 2 times x and make that 2x instead. So 2x plus 3 equals 15 would be that one. That makes that A. Okay, number 4, a number and 3 combined is 15. So a number and 3 combined, combined means add, is 15. And there's nothing to even do to that one. That's all you have. X plus 3 equals 15 makes that choice D. Okay, number 5 is 2 times a number increased by 3 times the number is 15. 2 times a number increased by 3 times the number is 15. And the cleanup for this would just be to put the 2 times x together and make it 2x plus 3 times x, make that 3x equals 15. And that's choice E. Okay, 2 more than plus 3 times a number is 15. And to clean that up, I'm going to put the 3 times x together and make it 3x. I don't see that as a choice in my list because normally the x term comes first. So let's flip that around and make it 3x. It's positive, so it's just positive 3x plus 2. This is a positive 2. So 3x plus 2 equals 15 would be my final answer for this one, which is choice G. Okay, for the next two, we haven't looked at anything like these before. In problems like these, they're asking you to actually come up with two different ways of writing things. And so I'm going to go through the steps on how to do this with number 7 and then repeat that whole process with number 8 so that it makes more sense. So let's talk about number 7 first. John is 5 years older than James. The sum of their ages is 15. So they're talking about two different people here, John and James. And then they tell you that the sum of their ages is 15, so that means you add them up. But in order to do that, we have to figure out a way to write each one of them. So anytime you're working with more than one variable here, like John and James, you have two, you need to make X one of them, and that's the one you know nothing about, and then you're going to write the other one using X. So I'm going to go back to this first sentence. It says John is 5 years older than James. I know nothing about James. So X is going to be James's age. I don't know a lot about John, but I do know that he's 5 years older. So what I can do as a way to come up with how to write John's age, if he's 5 years older than James, then he's got to be James's age plus 5. James's age we said was X, so it's James's age plus 5 if he's 5 years older. Okay, so now I have a way to write both people, and then I'm going to use the information from the second sentence to come up with a way to write an equation for this. So the sum of their ages, so James's age plus John's age, the sum of those two is 15. Okay, so there's my situation here. Now I said that James was X. And I said that John was X plus 5. And that has to equal 15. So there's my equation. And then I'm going to try to clean it up a little bit. So when I go to look at this, I see that on the left side of my equal sign, I have two terms here that can be combined. Here's an X, here's an X. They both are 1. So together, 1x plus 1x would make that 2x plus the 5, and that equals 15. So there's my equation. That means that's choice F. Okay, let's try to do the same thing for number 8. A writing tablet costs 4 times the cost of a box of pencils. The cost of both is $15. So I'm talking about two different things again. So the first thing I want to do is figure out which one do I know nothing about. That's the one I'm going to make X. So the writing tablet costs 4 times the cost of the pencils. I don't know anything about the pencils then. That's my X. I don't know much about the writing tablet yet, but I know that it is 4 times the pencils. So 4 times the pencils. We said the pencils were X. So 4 times X will be how I'm going to write the writing tablet. And together, the cost of both is $15. So the pencils plus the writing tablet equals $15. And then for the cleanup, these are both X terms that are on the left side, so I can put them together. So this is a 1x. 1x plus 4x is 5x. These two combined equals 15. There's my final equation for that one, and that is choice C. Okay, for the remainder of the problems in this section, we're going to use the skills that we just talked about with translating just regular sentences, and we're going to apply it to actual real life situations now. So for number 1, patient A receives 3 times the amount of a certain medicine as patient B. The 2 doses add to 200 milligrams. What amount of the medicine does each patient receive? So just like what we just finished up, you're talking about 2 different patients here. So we're going to have to figure out how we're going to write this. So patient A receives 3 times as much as patient B. I don't know anything about patient B then. That's my X. And then to write patient A, I'm going to go back and see what they told me. Patient A receives 3 times patient B. So patient A receives 3 times as much as the other one. The 2 doses add to 200. So patient B's dose plus patient A's dose add up to 200 milligrams. So there's my equation. And now this time, instead of just translating, we're going to actually solve them. So on the left, I have like terms that I can combine. So x plus 3x, this is a 1x, is 4x. Bring down the 200. And now at this point, you have all of your x terms on the left and your numbers are on the right. So you're going to divide by the coefficient. So divide both sides by 4 so that we get x by itself. And 200 divided by 4 is 50. Okay, now what we just solved for x is what we said patient B's medication was. We said x was patient B. So we just came up with that one. To figure out how much patient A gets then, we're going to have to plug in 50 in place of the x here that we set. And that'll tell us how much this person's going to get. So 3 times x is 50, will be patient A. 3 times 50 is 150. So there's your 2 amounts. Patient B gets 50, and patient A gets 150, which should make sense because the total of those 2 combined would give you the 200. Okay, for number 2, they tell you that a business can calculate the assets of the business with a formula. Assets equals liabilities plus the owner's equity. So they're giving you an equation up front and then giving you some values. If a company's equity is $340,000 and liabilities are $195,000, what is the value of the company's assets? This is a case where you have an equation and you're given numbers to evaluate the equation. So we're just going to substitute in and solve for what they're asking for. They want the assets. So the assets is what we don't know. We'll plug in the liabilities as 195,000 plus the equity. The company's equity is 340,000. Okay, so all we have to do is add those up. So I plugged it in, and I'm getting 535,000. And that one's done. For number 3, it says a bookkeeper needs to post the cost of a desk and chair into his records. The cost of the desk was 5 times the cost of the chair. The total cost of both the desk and the chair was $720. What was the cost of the chair and what is the cost of the desk? So we're asked for 2 different things. So the first thing I'm going to do is set this up and then go back in and see which one I don't know anything about. So it says the cost of the desk was 5 times the cost of the chair. I don't know anything about the chair then. So there's my X. Then to write the desk, I'm going to go back and see what they told me. The desk was 5 times the chair. So 5 times the chair. 5 times X. There's my desk. Okay, so I have them both set. Now I need to write an equation. The total for both was 720. So X plus 5X, the total for both was 720. So there's my equation, and now I can solve it. So over on the left, I have like terms. I'm going to combine those together. X plus 5X is 6X. And my X's are on the left by themselves. The numbers are by themselves on the right. So I need to divide both sides by the coefficient, which is the 6. That way the 6's will cancel, and X is 120. Now let's make sure that we solved for the right thing. The X was the chair. So the chair is what they asked for. The chair is the 120. Okay, for the cost of the desk, then I need to go and substitute in the 120 that I just solved for in place of the X right here. We said the desk was 5X. So we're going to change the X to what we said it was. And then 5 times 120 is 600. There's your cost of your desk. All right, so let's take a look at number 4. It says in an 8-hour and 30-minute shift, a patrolman drove 272 miles. What was his average rate in miles per hour during the shift? So when I look at this, I see that they gave me an equation to use, and basically what they want us to do is evaluate it for the values that they gave us in the problem. So when I go through here, I'm going to look for each of these, the distance, the rate, and the time, and I'm going to substitute it in. So first, let's see if they gave us the distance. It says he drove 272 miles. So that's the distance. For the rate, that's what they're asking for. What was his average rate? Since we don't know it, that'll become our X. And then we need to multiply that by the time. But we got to make sure that we are in the right unit here. If the rate is in miles per hour, then we need miles and we need hours. So the distance was miles. The time has to be hours. We are given 8 hours and 30 minutes though, not just hours. That means we need to convert the amount of time that is not in hours so that everything will be in the right unit. So the 30 minutes has to be converted by dividing it by 60, because there's 60 minutes in an hour. So you have 8 whole hours plus a partial hour, 30 minutes. 30 over 60 is a half, 0.5. So instead of saying 8 hours and 30 minutes, it's like just 8.5 hours now. And now our time is in the correct unit. Now I can substitute it in. Okay, so that's the first part. Now I need to solve this. So I'm going to clean this up a little bit, and I'm going to put 8.5 times x together and make that 8.5x. And then in order to solve this, I see that I have x's alone on one side and numbers alone on the other side. That means I can divide. If I divide both sides by the coefficient, that'll tell me what x is. So the 8.5s cancel, and x is now by itself, and 272 divided by 8.5 is 32. So his average rate was 32 miles per hour. Number 5 says, at the end of the past month, the cash account of the company has an ending balance of $6,750. During the last month, the account was debited for a total of $11,350 and credited for a total of $10,500. So what was the balance in the cash account at the beginning of last month? And then they gave us a formula to use, so we're going to just substitute in and evaluate it for the values that they told us. So they are looking for the balance at the beginning of the month. So that's the one we don't know. That means we need to know the debits, the credits, and the ending cash. So let's see what we have. For the debits, the account was debited for $11,350. Minus the credits, it was credited for $10,500. And then the ending cash, it had an ending balance of $6,750. So there's our equation. Now let's see what we can do to solve it. When I look at the left side, I have the x term, but then I have two constant terms. So I can combine those together. So 11,350 minus 10,500 is 850. So I'm going to put those two terms together. It's 850. And I'm going to bring down everything else. Now when I look at this, I have x is over on the left, but the numbers need to go to the right. So I need to move this 850 over. Since I'm moving it, I got to do the opposite of what's there. So I'm going to subtract 850 from both sides. And gather it back up. Since these are backwards, those cancel. That's what I want. I want it to say x equals, and then I need to subtract 6750 minus 850, which is 5,900. Okay, so x equals 5,900. That means the beginning was that. Okay, number 6 says the Clean and Shiny Car Wash Company charges $95 to detail a car. They detailed 75 cars during the past month, and their expenses are given in the table below. Calculate the company's profit for the past month. So here's all of their expenses, and profit is given to us with a formula. So we're going to have to plug in to solve this. So if they want the profit, that's what we don't know. It's going to be $95 times the number of cars detailed. They detailed 75 cars, so that gets substituted, and then it's minus their expenses. So to figure out their expenses, all I did was add up everything that they have, and their total expenses is $2,705. I got that from this table right here. Add up all of these. Okay, so now I need to work this out with the order of operations. So I need to do the multiplication first. So 95 times 75 is 7125 minus 2705 is 4,420. So there's your profit. Next up, number 7 says the ABC company has a net income of $56,000. Assets at the beginning of the year are $263,000, and assets at the end of the year are $313,000. What is the company's return on assets? And they give us another formula to plug into. They're asking for the return on assets, so this is the thing we're being asked for. We don't know it, so I'm going to call it X. Equals, now I need the net income. So the net income they told us was $56,000. And I need to divide it by the average assets. They didn't tell us the average. They told us the beginning and they told us the end. So we're going to need to find the average. I'm going to do that off to the side. To find the average, you add up and then divide by however many you have. So we only have 2, so we need to add these 2. Okay, so that gave me 576,000. And I'm going to divide it by 2 because there's 2 of them up here. So 576,000 divided by 2 is 288,000. That's the average assets then. And that's what's going to get plugged in down here. Okay, and now we just have to divide these 2. and that'll tell us the return. So 56,000 divided by 288,000 is 0.194, and that 4 is repeating. So as a percentage, because that's usually how they write their return on assets, we multiply that by 100, and that's about 19%. All right, and for number 8, it says the number of pages in the U.S. tax code exceeds the number of pages in the King James Bible by 18,528. The combined number of pages in the tax code in the Bible is 21,472. How many pages are in the Bible? And how many pages are in the U.S. tax code? So we're back to trying to set up something for two different variables. So we're going to start with calling x the one we know nothing about. So let's go back up and look. It says the pages in the U.S. tax code exceeds the pages in the Bible by that. So we don't know anything about the King James Bible. That'll be the x. And then to write the tax code, we're going to use x. The tax code exceeds x by 18,528. Exceeds means plus, so we're going to write x plus 18,528 as a way to represent the tax code. Okay, now that I have those two set, now I'm going to create an equation using this information. The combined number of pages in both of these is 21,472. So if I combine the pages in the Bible and the pages in the tax code, x plus 18,528, that whole thing is the tax code combined with the Bible, that equals 21,472. All right, and there's my equation that I can solve now. So let's see what we can do. I have like terms right here with these two x's, so I can combine those together. X plus x is 2x. Bring the rest down. And then my x's are on the left, so I need to get the numbers all to the right. That means that this needs to move, and I need to do the opposite. So I'm going to subtract. And I'll do that to both sides. And recombine and see what I get. These are opposites, so those cancel. We've got 2x over here, and 21,472 minus 18,528 is 2,944. 2944. Okay, so now I have all of the x terms on the left and the numbers are on the right. So this is where you're going to divide by the coefficient. So divide both sides by 2. That way these 2's will cancel and x will be by itself. So I get a final answer of 1,472. Okay, so since X was the Bible, we just answered the question for the Bible. To figure out how many pages are in the US tax code, then I'm going to plug in the amount that we just got in place of X right here. So I'm going to plug in 1472 in place of X. And I'm going to add this 18,528 to it. And that's exactly 20,000. So this is the amount of pages in the Bible. Here's your tax code. And that's done. That's the end of this unit. So please go back and review all of these notes that we've just gone over. Get prepared for the next exam and the quiz that's coming up.